Hey everyone, welcome to Orlando. I've mostly unpacked my office and I just got back from Defcon and I got this cool Rabbit Labs 33 Defcon shirt and hat. I also got some official Defcon merch and a new portable SDR radio. And Rabbit Labs gave me a battery to put in that radio. Rocket God gave me that cool coin. Over here from Midwest Gadgets, I have something that connects to the back of your Flipper Zero and uses this wire to connect to this RFID antenna card. So you can just tap it. From Rabbit Labs, I got this cool case that goes on the Flipper Zero. And then from Sparrows, I got a variety of locks and repin kits. That's the official badge this year. And this was another really cool badge. This badge was from Danner, so check out his website. And then I also have the Defcon bag. This is actually my second video on the Chameleon Ultra, which is a small device that does RFID. I'll be using the Chameleon Ultra Dev Kit in this video. And the Dev Kit allows us to easily access the different pins on the Chameleon Ultra. So we'll be able to use our Flipper Zero and see the logs that are coming off of our Chameleon Ultra. My hope is that some of you will implement low frequency RFID protocols for the Chameleon Ultra. And the first step for that is setting up our development environment. Let's get started. In this video, we'll be using Ubuntu as our operating system, and we'll use version 25.04. So go ahead and click download on that Intel or AMD 64-bit architecture. I'm running Windows, so I'll go ahead and download VirtualBox for the Windows hosts. And I'll also accept and download the VirtualBox extension pack. Before we install VirtualBox, bring up Task Manager, go to the Performance tab, and make sure virtualization is enabled. If it's not enabled, look up the directions for your motherboard. Next, we'll go ahead and launch VirtualBox Setup and just accept all the default values. You should now run the Oracle VirtualBox Manager. Go ahead and click New to create a new virtual machine. And then we'll go ahead and name our machine. I'll just name it VM1. And then for the ISO image, browse to the location where you saved your ISO for your operating system. And it should auto-detect the type, subtype, and version. I'm going to say skip unattended installation. For me, when I use the unintended install, I got this something went wrong message. Next, in the hardware tab, we'll go ahead and increase our base memory. Make sure you're in the green range, but just give it a reasonable amount of memory. And then I'll also increase the processor's count, typically to about 4 or 8, something like that. And then under hard disk, I don't know if this matters, but I've seen other people choose 60 gigabytes, so that's what I'm using as well. Next, we'll go ahead and start our virtual machine. And I'll go ahead and speed up this part of the video so you don't have to watch it slowly install. And then click through on Next until you get the Update Now button. Go ahead and choose Close Installer. And now you should have a shortcut on the desktop that you can launch the install process. So choose your language. And then go ahead and say Next for accessibility, Next for the keyboard. Wired connection will use, it's a virtual machine, so it'll just still use, if your computer's wireless, that'll work. And then go ahead and say interactive installation, default. I'm going to choose third-party software for graphics and Wi-Fi. I don't know if that actually works inside of a VM. And then this erase disk is talking about our virtual disk. I'm not going to bother with encryption. And then here, go ahead and enter your account name. I'll just do MDJ for Mr. Derek Jameson. And then type in a strong password. I'm going to use a fair password for this video, so it's easier for me to type. Choose your region. and then go ahead and click install. At this point, it'll run through the installation, installing into the virtual hard disk. And then after a few minutes, you should get the message that it's installed and ready to use. Go ahead and click Restart Now. And then when you get the please remove installation medium and press enter, just go ahead and press enter. Your system should reboot and you should get the login screen. Go ahead and click on your account and type in your password. At that point, you should get the welcome screen and go ahead and click through those options. After a few minutes, you should get a message about updates being ready to install. Go ahead and install those updates. Those should just take a couple minutes to install. And then once those updates are installed, go ahead and do the restart now. At this point, we're ready to set up our development environment. I'll go ahead and open Firefox. And we'll go to code.visualstudio.com, whack docs, setup Linux. Click on the first link there, download and install, and then click on that .deb package. So that will download into our downloads folder. So we can go ahead and open a new terminal window, type terminal, and then in here we can cd, change directory, into that downloads folder. ls lists the files in the current directory. We'll go ahead and do sudo apt install / and the name of that code file. And then we'll type in our password. And this will install Visual Studio Code. Then we'll go ahead and say yes to add the Visual Studio Code repository. And at this point, Visual Studio Code is installed. Next, I'll go ahead and do a cd ... to go to the parent directory. And then we'll go ahead and install the get tools. So sudo apt install git, and then say yes to continue. We'll now have the get command installed, which will allow us to clone GitHub repositories. Next, we'll run sudo apt install cmake, and then say yes to continue. And then sudo apt install python 3.13-venv. sudo apt remove modem manager. And modem manager is one word. We'll type in who am I to get our account name. Mine is MDJ. And then we'll do sudo usermod -a capital G dial out, and then our username, which was MDJ in my case. So modem manager will no longer interfere with flashing our device, and the dial out will let us access the serial port to flash our Chameleon Ultra. This next command is because libincurses.so.6 is what's installed, but our GDB debugger is expecting to find version 5. So we'll just map so that when it looks for version 5, it uses version 6. We'll also map version 6 of libtinfo to version 5, but I'm not sure if that step is necessary. Now we'll go ahead and reboot our virtual machine, and the rebooting will cause our user account to get that dial out group. And then go ahead and log in once it's rebooted. So it turns out I forgot to run the sudo apt-get install bzip2, but we'll run it later in the video. Next, we'll open our web browser and we'll go to github.com RFID research group, Chameleon Ultra, and then open the wiki tab. At this point, we can follow the steps that are in the development page on the wiki, and I will walk you through these steps in a moment. But basically, you're just going to follow everything in here. And then also the CLI, which is how we can interact with the Chameleon Ultra from our computer. As a quick aside, if you go to Insights and then Forks, there's the RFID Syndicate fork. A few of the people from Defcon created this fork, and I'm a member of this fork. So in some future videos, we may be using this code dropdown instead of the official repository. For now though, we'll go ahead and go back to the official repository. The first thing we need to do is clone the firmware. So go to the Code tab, click on the green Code button, and then copy URL to clipboard. Open a new terminal window, and then in that terminal window, type get clone -- recursive, and then right-click paste that GitHub URL. Next, we'll do a CD to Chameleon Ultra, and then ls to list our files. And then we'll do a get tag to see which tags are associated. If you've forked this from a different repository instead of RFID research group, you'll need to go in and grab the tags from 2.0. Here's the commit number. Go ahead and click on that. Copy the commit ID to your clipboard, and then do a get checkout, and then right-click, paste in that ID. Now we're on that ID, and now you can do a get tag v 2.0.0. And I'm not going to actually do it. I'm going to go ahead and press Control-C instead of Enter. And then once you've done that, you should be able to type in get tag, and you should at least see a v 2.0.0. That tag is neat as part of the build process, but now we're ready to go ahead and do a get checkout main, and this will put us back into the main branch. Over on the GitHub wiki, we'll switch to the development page, and then we'll scroll down, and I'll right click on this first link and say open a new tab for the GCC ARM None tool. Go ahead and accept that, and then I'll do a search for x86 _, and we can see that linux.tar.bz2 file. Go ahead and click that to download. In our command window, we'll do a cd /downloads, and then ls shows us that new GCC ARM file, mkdir /.gcc-arm, and then tar-xvf, and then the name of the GCC file, -- directory, and our output directory. It looks like I forgot to install bzip2, sudo apt-get install bzip2. And then once that's done installing, we can rerun the tar command. So now that that's done, we'll go ahead and close that tab. And the next step is to install make. So I'll go ahead and copy this command to my clipboard. And then in the terminal, I'll go ahead and paste and press enter. Next, we're ready to go down to the next step, which is installing the NRF tools. I'll go ahead and right click and open the NRF util in a new tab, accept the cookies. And then here's a downloads button. We'll pick our platform as Linux x64, and then that file will download. So switching back to our terminal window, if we do an ls, we see that new NRF util file. We'll go ahead and do a sudo mv NRF util into /usr/local/bin. So this is on our path already. And then we'll do a sudo chmod +x /usr/local/bin/NRF util. So now this file is an executable that we can run. So the next step is to install the NRF util packages. I'll go ahead and copy that to my clipboard. But before we run that command in the terminal, we'll go ahead and do NRF util and self-upgrade. And this will update the NRF utils to the latest version. Now we're ready to go ahead and right-click paste that NRF util command. And then the next step over in the wiki was the NRF command line tools. So again, I'll right-click, open a new tab. And this one is a little bit tricky. On the choose the platform, make sure that you've picked Linux x86 64. Go ahead and click on that. And then up above, you'll see 3 links, and we want the amd64.deb file. Back over in our terminal window, we'll do an ls and we can see that new file. And then we'll do a sudo dpkg-i and then the NRF file name. And then at the last part here, we'll copy that to our clipboard, right click, copy, and then right click, paste. And this is a sudo apt install command. I'll go ahead and close that tab. And the next thing on the wiki is to install OpenOCD. So we'll go ahead and right click, open link in new tab. And then over here, you'll see that the command is apt-get install OpenOCD. So I'll go ahead and copy that to the clipboard. And we need to do an sudo before we do the apt-get commands. So we'll do sudo and then apt-get install OpenOCD. At this point, we've got pretty much everything installed. We're at the configure the project step where we need to edit our makefile.defs. So back over on our terminal, I'm going to do a cd tilde, but if you open a new terminal window, that's where it would be. And then cd Chameleon Ultra, and then code space dot. And this is going to open our Visual Studio Code. Yes, I trust the authors. Under the firmware folder, you'll see the makefile.defs. And so our goal here is to update the GNU install root in the GNU install version. So we installed those tools a lot earlier in the process, you'll remember. So we'll do an ls tilde /gcc-arm/gcc, and I just tab to get that full path, /bin, and then /arm-none eabi-dcc. So this is our GCC tool. This only needs the path of where this tool is found. So we only need up to that bin folder. So we'll go ahead and copy the bin, including that trailing slash. And then our version here is 10.3-2021.10. So we'll go ahead and paste that in. So that's all we need for the build to work. But there's also on line 35, this NRF log UART on SW0 enabled. And if you set that to a 1, serial port will be used for outputting your logs on the SW0 pin. The blue LEDs don't work on the Chameleon Ultra when you do that, so I'll keep it as a 0 for now. But in a future video, when we do some debugging and look at logs, that's what you need to change to a 1 so you get those log files. The C++ extension and extension pack are here, and the IntelliSense configuration didn't work for me, so I'll do that in another video as well. Was not critical to do. If we go into application source app main, you'll see we are already getting syntax coloring. So I think that means the C++, but there is a C++ extension pack. So I'll go ahead and install that extension pack. So at this point, the next step is compiling the code. So over in our terminal window, we are currently in the /Chameleon Ultra. So we'll cd into that firmware folder. And you can see the build.sh is here. So we'll do ./build.sh. And this is now building all of our firmware for the Chameleon Ultra. Now that it's built, we're ready to go ahead and flash our Chameleon Ultra. I usually use the DFU app.sh, not the full.sh. The app has less chance of having to do any kind of recovery to your Chameleon Ultra if things went wrong. So we'll go ahead and do the flash DFU app.sh. But before we do that, we need to plug in our Chameleon Ultra and expose it to our virtual machine. So if you right click on this little USB icon, you'll see your Proxcon Chameleon Ultra. And then you can click on it. And now when we look at it, it is attached and you see a check mark. So we're ready to do our flashing. It just put the Chameleon Ultra in DFU mode. So now when we right click, we see it's no longer connected. We'll click on that so that it is attached to our USB. And now it sees that device and is flashing our firmware. So at this point, our Chameleon Ultra firmware is getting a new application installed on it. Okay, and that's done. And now when we right click, we can see that the Chameleon Ultra is not attached because it's, again, the original one that we just flashed. So we attach it now. And now we're ready to move on to the client side of things. So I'll do cd dot dot and cd dot dot. So we're in that tilde folder. And now on the wiki, we're ready to go into the CLI page. This is actually a lot easier than it looks. All of these requirements we've already installed. We've already done all this Python 3 stuff. So we can just click copy on this big script. And then over in our terminal window, when we're on that tilde directory, make sure you're in tilde, we can go ahead and choose paste. And then press enter. And at the top, you saw there was a fatal error. That's just because it's trying to clone the Chameleon Ultra firmware, and we've already cloned it in the previous steps. So that can be safely ignored. There we go. So now all of that's ready to go. And then to run the client in a new terminal window, or because we're in the tilde folder, we can do it in this window. We're just going to run these commands. So I copied that to the clipboard. We'll right click paste and press enter. And there we are. We're in the command line interface. Our Chameleon Ultra is attached. So I'll go ahead and do a HW connect to connect. And we've connected via USB. And then I'll do a HW slot list to list the different slots so we know that we're talking to our firmware. So both the command line interface here that we're running and the firmware are from the files that are on our computer. So at this point, we're ready to start development and create new features. In Visual Studio Code, if you look, here's all the different files for that firmware. And then under software scripts, here are the Python files, which is what the CLI is written in. In a future video, we'll go ahead and look at how to add new protocols, low frequency RFID protocols to the Chameleon Ultra. And we'll also look at how to do debug logs on the Chameleon Ultra. Please like and subscribe. And if you have any questions, leave them below or contact me on Discord.